o'clock or 11 to 11 onwards, the peak. Okay, at peak time you consume the power, or non-peak hours. Night, let's say 2 o'clock or 1 o'clock. Even if you consume the power, you have to pay same amount. But because consumer don't know how much per unit cost. But if you have, that is when peak hour is there, instead of 5 rupees per unit, I will make it 25 rupees per unit. Therefore, how the meter should show, if you press a button, the cost goes on changes, therefore you should indicate 25 rupees per unit. If I switch on my AC, I will be afraid 25 rupees per unit means I will switch off. That is why consumer management, the demand side management also will come into picture. That is. Therefore, in this one, therefore the smart meter is the building block for the smart grid. If you see the definition of the smart grid, a smart grid is an electricity network that can intelligently integrate the actions of all users connected to it, generators, consumers, and those that do both in order to efficiently deliver sustainable, economic, and secure electricity supplies. The smart grid, another definition, smart grid is an electricity network that uses digital, because everything is digital, that is analog, whatever we're having sensors or anything, uses digital and other advanced technologies to monitor and manage the transport of electricity from all generation sources to meet the varying electricity demands of end users. Therefore, as I mentioned, it will have several things for basically power system, power electronics, communication, that two-way communication. Why? What is the need for two-way communication? As of today, we are having only one-way communication, that is from substation to consumer side. But consumer to substation, we doesn't have. That is why if you're having a smart meter, if you press a button, what is the rating? What is the cost of the per unit? Therefore, you should give that we require a two-way communication. Otherwise, we will not get an information technology. And this four will play a vital role. What are the attributes of the smart grid? We see some of the attributes, advantages of this smart grid. Self-healing. If you see our old power system somewhere, some in forest, some problem is there. Some line has tripped means sometimes automatic breakers are there. They will switch on after the fault clearing. But if it's not there, people should go to forest. Then only they clear the fault like that. It will take a headache. If there is a power. Power problem occurred, okay, fault occurred during night time, only persons will go only in the morning. Therefore, until morning, we doesn't have any power. But here in this one, it is as I mentioned, smart is nothing but intelligent and automation also. So based upon this automation, when fault is occurred, it automatically clear the fault and or isolate the fault section and make it as a islanding case. That self-healing itself will heal. Power disturbance events. It enables active participation by consumers in demand response. As I mentioned, when you're having the smart meter, then only consumer will participate in the demand response. If the cost is more, he will switch off. He will switch off his heavy loads like geyser as well as the ACs, etc. Normal loads they can switch off. And it operates resiliently against both physical and cyber attacks. And most of the time, as you might have seen, cyber physical systems. The physical systems are nothing but our generation, transmission, distribution. Cyber is nothing but with computer and calculation based those things. When attacks are there, how to again minimize resiliently against both physical and cyber attacks. Accommodates all generation and storage options for electric vehicles. Therefore, most of the time in future, suppose if you say some country, advanced countries, somewhere having large electric vehicles are standing for to receive the customers. Therefore, meanwhile, they can, if you plug in grid to vehicle to grid, also we can pump the power, or if required, grid to vehicle also we can pump. Therefore, this electric vehicle also will act as a storage device. It enables new products, services, and markets, and optimizes asset utilization. And operating efficiency increases, as well as the optimally we can utilize the assets. Assets means we're having whatever we're having generator, transformer, transmission, etc. and all. Okay, if you see some from where we are going, central generation and control previously. At present we are having central and distributed generation with intelligence, because each and as on today, most of the houses also they're having the solar power. Therefore, it is a distributed generation. And load flow following Kirchhoff's laws, load flow control power electronics, and power generation according to load demand. It is a controllable generation, variable in feed and demand in equilibrium, and manual switching and trouble response, whereas the smart grid, automatic response and predictive avoidance. Predictive means it will predict, because most of the time we talk about, I will talk, in machine learning I will talk, the most of the time what we will do is that this a generator is there. It maintenance after 6 months. Today we have done means after 6 months only we will do. That is the maintenance general. But predictive maintenance is that it is not reactive. That is, because of this one, this machine learning, this some of the application AI applications, we can predict. It need not be, because based upon the requirement, we need not wait up to 6 months. Within 3 months only, sometimes it may come for the maintenance. That type of things also we can predict based upon someone or AI algorithms. That is why automatic response and predictive avoidance. Therefore, we can avoid, if you instead of 6 months if you wait, some problem some incident may take place. Therefore, to overcome predictive by using predictive algorithms and all that, we can, which is the more priority, then we will go for the maintenance. Deterministic response of power flow. Everything is deterministic in the old our power system. In smart grid, monitored overload of bottlenecks, periodic maintenance. Okay, and it is a periodic maintenance. It is prioritized condition based predictive maintenance. Prioritize which is more important. We will go. If it is 6 months is there, sometimes we will go within after 1 month also. We can go for the maintenance based upon the requirement. If it is existing and intelligent grid or smart grid, whatever it may be, everything is electromechanical, digital is required, and one-way communication, two-way communication, centralized generation is distributed, because the renewable sources plays a vital role in the future, and hierarchical, few sensors and throughout the network, whereas the sensors, it is blind, as I mentioned, when fault occurs in some deep forest, one should go and clear the fault. But it is intelligent, self-healing. Whereas manual restoration, it is adaptive and aligning, and failures and blackouts will be there in the existing grid. And manual check, and it is a remote check, limited control, pervasive control throughout the system. We can control in the smart grid. Few customer choices, many customer choices. Okay, to see this, because at the time what the committee has suggested, in place of SCADA system, you replace all PMUs. But to replace PM is not a simple job. Each PMU will cost few lakhs, 5 to 6 lakhs. Therefore, slowly government they are keeping installing the PMUs. Therefore, we are having SCADA system also is there, as well as the PMUs also there. So if you see some of the features of the SCADA as well as the PMU, we see the measurement. It is analog, or it is digital. Resolution point of view, that is how many measurements you will get per cycle. With respect to Indian scenario, the frequency is 50 Hz, the 20 milliseconds, we can get only 2 to 4 measurements I will get. Whereas PMU, based upon the hardware, we can get nearly 60 samples as of today, but in future we may get more than that also. And observability, steady state, and dynamic and transient. And monitoring local area, the small area, the SCADA system, wide area in a large area, you can get PMUs data you can get from large areas. And the most important feature is that phase angle measurement. As I mentioned in the beginning also, SCADA will not measure angle, because it can measure, but costly, that therefore most of the time people will not measure the angle, only magnitudes. But SCADA, PMU inherent characteristic, as I mentioned, voltage magnitude and phase angle, current phase angle. It measures only these two, with magnitude and angle with respect to time reference. Therefore, the components of the smart grid, say, metering, as I mentioned, the smart meter is a must, because in Hyderabad also, one benchmark project in GD Metra is there, in the United Andhra Pradesh, okay, in implementation. Therefore, if you want to go for the in Pondicherry, also implement, that is 14 places in India. Therefore, to implement this pilot project, first of all, we should select an area, and all in that area, all the houses should be household or any industry is there, it should be equipped with smart meter. Then only we can do this smart grid or the different functions. Therefore, metering automation, advanced metering infrastructure (AMI). The difference between metering as well as the advanced metering infrastructure is nothing but it indicates the communication lines, meters. Meters may PMUs or smart meter, or it can be IGD, intelligent electronic devices. All the things which are related for the metering which are required will come into picture advanced metering infrastructure, because most of the time in literature people will give, instead of calling a whole smart metering and all that, they will use the word AMI, advanced metering infrastructure for residential. Something is required, advanced metering infrastructure for the industry. Something is required. Therefore, apart from the meters, communication links, etc. Therefore, they will call as the AMI. AMI plays a vital role as of today. People are doing a lot of research in the meter placement, etc. in the power system as well as distribution system. Because most of the time the research is going on in distribution, automation or distribution system. Is microgrid, everyone knows that is fuel cell, dispatchable generation, fuel cells, micro turbines, IC engine, intermittent generation, that is which is based upon the wind velocity as well as nature dependent, that is the radiation and all that, wind turbines and solar photovoltaic. Okay, the dispatchable generation, intermittent generation, and storage by using batteries, ultra capacitors, electric vehicles. Hello, not visible. Okay.
Sir, PPT కనబడలేదు సార్.
Yeah, I'm sharing. No, is it visible? No?
Then what?
Shall I join once again otherwise? Hello? After that, I want to share this arrow mark, but it is not coming. It is not visible. Can you give the permission for starting this one? It is giving only meeting organizers and presenters can share. Has given permission? Hello? Hello, Saravanan? Okay. 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 No, it is not highlighting. Rejoin. Okay. 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 Now it is. Okay. Now it is visible?
Yeah, not visible, sir.
Okay. Kishan, I will talk you later. I will talk. I'm in the meeting. I will call. I stopped at a particular point. Once again, you are able to hear?
Yes, sir.
Okay. Dispatchable generation, intermediate generation, and storage. If you want to directly whatever you generate, we can pump it to the grid, or otherwise using storage is there. You can store, and we can, whenever required, we can make use of. And with respect to the smart grid, you will have the 7 working groups are there in India. Generally, the chairman for this smart grid working groups, Sham Petoda, is the chairman. In this one, working group 1, advanced transmission, they will take care of. That is, they will talk about, they will do some research in PMUS, WAMS, wide area measurement systems, that is the wide area control, wide area monitoring, wide area protection, and fax devices, etc. Because of this blackout, India also we're having, still we're having SVC only one at IIT, at Kanpur, but we're having several TCSs they installed, Government of India. And working group 2, they will advance distribution. They will do some research in the SCADA system, DMS, substation automation, self-healing, distributed generation, power electronics, etc. Working group 3, communications, because as I'm today, without communication, we cannot go for the smart grid. Therefore, that two-way communication is required. Working group 3 will take care of this one. Working group 4, metering, that is smart metering is must, because as I mentioned, in future, these electronic meters are also replaced with smart metering. And working group 5, consumption and load control, that is demand response, home automation, appliances, storage, etc. And working group 6, policy and regulation. And working group 7, they will talk architecture and design of smart grid. Therefore, in the smart grid, the standards are required, because everything will some standard. It should be IEEE standards or whatever it may be. There is one NIST institution is there. They will take care of. But in India, working group 7, architecture and design, they will talk about. And in this one, common information model, SIM models are play a vital role. This NIST, National Institute of Standards and Technology, okay, and they will impose some standards. Transmission means some standards are like this and all that. They will impose the standards in all: generation, transmission, distribution, customers, operations, markets, and service providers, etc. The NIST Smart Grid Conceptual Model helps stakeholders, that is end users, understand the building blocks of an end-to-end smart grid system from generation to customers and explores the interrelation between these smart grid segments. And this smart grid, as I mentioned, power system, power electronics, two-way communication, as well as the IT information technology. Therefore, in the IST, what people are doing is that the power and energy layer, okay, three layers, the concept they came for power and energy. In this one, power system, power electronics will be there, and communication layer, and another one is the IT layer. Therefore, this is a conceptual model of the smart grid. Okay, good old days we used to talk about this generation, transmission, distribution only. But here, apart from the generation, transmission, and distribution, a customer also will come into picture in smart grid. The customer will play a vital role in the demand side also. Okay, bulk generation, transmission, distribution, and customer. This four, and they are bi-direction. And you'll have here markets, operations, and service providers. Bulk generation. The generation point, if you see, wind and solar, renewable and variable, they will vary based upon the weather conditions and all that. And renewable, non-variable, that is hydro, biomass, geothermal, pumped storage. And another one, renewable, non-renewable, non-variable, that is our conventional nuclear station, coal, as well as the gas. Distribution system point of view, that is the distributed storage, okay, where all solar, wind, etc., and all that, wherever you want. And distributed the generation, it can be wind, what we have said, it is wind, it is a solar, and capacitive banks, several things will come into picture for the distribution. From there, it is going to the transmission, markets, customer, as well as the operations point of view. Customer point of view, here we will have the most of the time customer, people will talk in smart grid, home automation, building automation, like the several things will come into picture. Therefore, in the home automation, if you observe, we'll have this meter, applications, automation, solar generation, etc. Industry, cogeneration, okay, and distributed generation, and the lighting, it will make use of industrial automation. And building automation, therefore every building, okay, meters and some renewable sources, etc. and all that. Operations point of view, we will have the network operations, as well as maintenance, financial, as well as the supply chain logistics, etc. Reading, and several things will come with the operations point of view. It is, if you see this network operations in this one, we will have the fault analysis, monitor and control of the load control, reporting and statistics and analysis. Markets, there is wholesale market, retailing market, as well as the ancillary markets. Ancillary markets, which are nothing but whatever. Suppose you want to maintain my voltage and frequency constant, the voltage is less. The ancillary market, I should purchase certain reactive power. Therefore, by injecting reactive power, my voltage will increase. Whereas in case of my frequency goes on deplete, I should purchase the real power such that I can maintain my constant frequency. Therefore, everything is in the deregulation point of view, nothing is free. One should purchase everything. Therefore, the markets will have the whatever we require. You can market the wholesale market and trading. We can sell the power online. Okay, we are having the Power Grid Corporation of India, as well as this power exchange. The power exchange is there in India. It is acts like stock exchange. The power exchange, the person who wants to sell the power, he will onlinely, he will indicate he want to sell so much of power. The person who want to purchase the power, he gives some bidding. That bidding strategies will come into picture. Those things we will talk about in the deregulation point of view. Therefore, trading, online trading also one can do, like stock exchange, power exchanges are there in India, and we can purchase whatever we want. Service providers, that is the billing, customer management, account management, etc. And for the building management, home management, and all. So these are some of the things with respect to smart grid. And as we have seen, blackouts which took place in India 30th and 31st July 2012, apart from the in India before in 1996, as well as the 2000 different countries also took place in USA and all that. Okay, the motivation, the synchrophasor technology, because Indian blackouts took place, the committee constituted by Government of India, they given some suggestions. One of the suggestions what you have seen, it is better to install synchrophasors or PMUs. Therefore, the motivation for the synchrophasor is one is the blackout. Second one, continuous load growth expected with the different generation mix. As the load is goes on increasing, therefore we require certain a generation mix, that is renewable sources and all that. And third point, the SCADA system not suitable for real-time control or time-critical applications, because as I mentioned, in the SCADA system, the measurements meters will be there, general meters. One measurement, another measurement, some delay will come into picture. To overcome the delay, committee suggested is instead of SCADA, it's better to go for the PM. And need for advanced real-time monitoring tools, and need for wide area control, that is PMUs. By using PMUs, we can use there for the protection, for the monitoring, as well as the control. And recent smart grid initiatives, that is the benchmark pilot projects in India, what we have seen, that is 14 projects in India, that also I will show. And Phasor technology, actually, it is developed by the Padke, okay, in USA in 82 to 92, is a protection person. When there is a digital protection is there, protection without GPU, it is a relay. When you incorporate the GPU, it will become a synchrophasor. The PMU or synchrophasor both are same. Okay. This PMUs one can use in the transmission system as well as the distribution system. In transmission system, people will use synchrophasor. In case of distribution system, people will call micro PMUs, because as I mentioned, the cost of each PMU is 5 to 6 lakhs. Okay, in transmission system it is fine. In case of distribution system, each substation is to have one PMU. It is very costly affair, 5 to 6 lakhs. Therefore, the cost is reduced because of some changes in the normal PMU. They are calling as the micro PMU. Therefore, the distribution system people will use micro PMUs. And this observe PMU, it looks like a relay. As I mentioned, without GPS, it is the relay only. Incorporate GPS, it will become PMU. Takes 3-phase voltages and currents. All measurements are time synchronized. Time is without time, there is no PMU measurements, and calibrate signal magnitude and angle called phasor. Streams the calibrated phasors at the rate 30 to 50 times per second. Okay, as I mentioned, up to 60 people we are getting based on the hardware, everything. PMUs enable observation of power system dynamic movements over a wide area, and compared to the 4-second SCADA data, the measurements are true synchronized and reported at higher rate and 30 to 50 times per second. Therefore, the advantage if you get in all measurements in real time, operator can predict what will happen next moment. Because the delay in one measurements are there, like SCADA system, what happens is that one measurement is coming at time T1, another measurement is coming time T2, another measurement is coming time T3. Even if you assume all are coming, whatever the output we are getting, it may not be that much accurate for real-time control of power systems. This synchrophasor definition is that a phasor is a complex number, magnitude and phase angle, used to represent the fundamental frequency component of voltage or current measured to a common time reference by means of GPS, Global Positioning System. This common time reference is independent of the geographical position of the measuring device. All measurements are done with the GPS 1 pulse per second as a reference, because if you want to measure the time with respect to time, all measurements should come is some reference should be required. The reference is 1 pulse per second. With this reference of 1 pulse per second, then all the measurements will come out of the PMU. If you have considered this PMU, it is a black box. Input is a voltage and current, normal voltage and current, and timestamp with 1 PPS. Output is the voltage and current, frequency, and rate of change of frequency you will get. That is the output. Therefore, those in particular voltage and measurement, these are all whatever the measurements we are getting, they are timestamp. With respect to time, you will get. These are certain 14 benchmark projects in India. If you see this in the United Andhra Pradesh, what we are calling in GD Metal Industrial Area, they will use AMIR, AMII, PLM, OM. If you see AMIR, Advanced Metering Infrastructure for Residential Consumers, AMII, Advanced Metering Infrastructure for Industrial Consumers, Outage Management, PLM, Peak Load Management. That means this GD Metal people, they will do these functions only. That is at 11,904 houses, they installed a smart meter. That is initial consumer base, and they will do AMIR. And one more thing, if you observe this Pondicherry, they will do only these two, AMIR, AMII, industrial as well as the residential. They installed smart meters in 87,031 houses. I think out of all 14 projects, this is the highest. And the PMU, it will have some analog inputs. We are given to it. It goes to anti-aliasing filters and A to D converter and Phasor microprocessors, okay, and modems and phase loop and GPS receiver. This is the simple block diagram of a PMU. Therefore, apart from the PMU, we will have some PDC as Phasor Data Concentrator. It is higher side Phasor Data Concentrator. Therefore, to the PDC, Phasor Data Concentrator, people will connect several PMUs. As in today, what is based upon the hardware, we can connect 6 PMUs. The data can transfer to the PDC. If in future hardware is enhanced, therefore more than 6 also can be connected to the PDC. Therefore, the PMUs are connected to the PDC. This is the data control concentrator and collector. People will call this a PDC instead. And from there, it will go to the advanced application because a load dispatch center, a PDC is there. Suppose the regional load dispatch, if you assume that one PMU is connected in each state, all the states' information will go to the PDC. The PDC is at the regional load dispatch center, like Bangalore for Southern Regional Load Dispatch Center, and they will do certain functions, the state estimation, automatic generation control, etc. Therefore, output of this one system, control, protection, functions, and like that. This global position system. Okay. Then the PMUs, the several vendors are there: ABB, Siemens, GE, SCL, Areva, and some other companies also they are manufacturing and they are selling this PMUs. Why a WAMS? Because most, as I told people talk WAMS, wide area measurements, wide area monitoring or measurement, both are same. Wide area monitoring, protection, and control. The 3 aspects we call as WAMS, wide area measurement system. And any WAMS, when you word which is used, WAMS means it is a PMU based. Therefore, the cascaded tripping and blackout cause huge disturbances in power supply. Partial or complete blackouts can be caused by wide area disturbances such as angular instability. Okay, angular instability, what happens? Generator will lose the synchronism with each other, and cascade tripping, etc. Therefore, wide area information acquisition is required for better system operation. This we see PMUs enable current and voltage measurements for dynamic monitoring of power system. That is, when talk online, is a must. And using real-time connection of phasor measurements from the power system into a central unit, it is possible to set up wide area monitoring, control, and protection platform for a real-time procedures. And as I mentioned, WAMS network is generic, a general word. It can carry both low-speed SCADA data or the high-speed PMU data also from the energy management system. The elements of the WAMS, the wide area measurement system, consist of PMU, phasor data PDC, communication network, and analytical software. Now, when talking about analytical software, we can see what is that analytical software. Collect data from PMU, PDC, the functions of the PDC, phasor data concentrators, higher side. The PMU collect data from PMUs and connect up to 6 PMUs as of today, and transmit data to remote control centers and store data in volatile memory as backup and industrial embedded computer platform without rotating components such as hard disk, cooling fan, etc. And if you see, just like what you have seen in the beginning, how the information flows or how the measurement flows from substations or generating stations to the through communication channel to the energy load dispatch center or energy management system. Here also by using PMUs, some substations and PMUs are installed. They will go to the PDC. From PDC, they will go to super PDC, a higher hardware, PDC like that. And in this control center or load dispatch center, if you see PMUs, go to the PDC, other PDCs, and from the PDCs, you go to the data control center, then they will do certain applications, monitor applications, control applications, etc. WAMS, it is based upon these three things, as I was mentioning: wide area monitoring and analysis, wide area control, and wide area adaptive protection. Okay, if you see some of the applications of WAMS, real-time observation of system performance and early detection of system problems. Okay, because instead of waiting, okay, what we have seen recently in the paper news, that is Srisalem, the left bank, some problem occurred because of the maintenance or what, we don't know exactly what is that. Therefore, early detection of system problems and real-time determination of transmission capacities, analysis of system behavior, especially major disturbances. And special tests systems for such as by using WAMS or PMUs or PDCs, special investigation of system dynamic performance we can do, and validation and refinement of planning models we can do, commissioning and recertification of major control system we can do, and calibration and refinement of the equipment, and refinement of planning, operation, and control process essential to best use of transmission assets. The research areas in this wide area monitoring and control is a wide area active control, okay, wide area that is adaptive protection and control, network management and devices, real-time network simulation, advanced sensors and measurements, distributed pervasive communication, knowledge extraction by intelligent methods. Okay, we can see novel design of transmission and distribution systems. These are some of the research areas. Now, when we install the PDC, PMUs, as a smart meter, several things, the large data will come into picture. So, as in today, you see, when data is large, we'll talk about some data analytics in this model. Most of the time, we are talking about artificial intelligence. That is, the artificial intelligence also one umbrella. We can talk about several things: your neural network, deep learning, deep neural network, as well as the machine learning. Several. So most of the time, what we are talking is that several applications are there for this machine learning and all that. Suppose you talk about a driverless car. When you are having driverless car, what is the requirement? See, okay, I will give some algorithms and all that I can, but it should behave like a human life. When you want it, it should not behave like a human. Okay, then only it can able to drive when traffic is there or highways and all that, can drive very well. But how can incorporate this common sense? Therefore, what as any algorithm from the beginning we are talking about neural network. Even data is there to learn we require training. Some data is required for the training. Some data is required for the testing and all. There, we talk about machine learning algorithms. Data is required for learning, and output of this machine learning algorithms, they will generate the model. Based on the model, we can take certain decisions. But whenever if you take like a car, what people are talking as in today. Reasoning. When automated reasoning, that is common sense reasoning, that reasoning also we can incorporate, then it will become, it can do better or equivalent to a human-like activities that can do. That is very, very important. That is just machine learning by using this automated cars, somewhat difficult. Therefore, we should add certain reasoning also. How do we add reasoning? It is the computer science. I'm not discussing those things. Therefore, if you see this data analytics with particular, because most of the time in power system or smart power system, what you will call or smart grid applications are very, very important. because you want to publish papers or you want to do anything. Otherwise, it is highly impossible. Therefore, because we are getting the data, large data we are getting in power system also, then we are using data-driven technologies. What are the data-driven technologies? Talk about data, everything based upon the data only. The neural network data is required, fuzzy logic data is required, machine learning data. Therefore, like machine learning, AI, we are calling AI, are becoming more and more popular. This data-driven is the use of data to guide action and policy, and using data to automate work, including decisions. If you want to automate, it should take decisions. When you are using this smart grid, then it is automation. Why we are calling, when, as you have seen one of the application, that is when a fault is occurred, it should become island. It will remove that faulty section, island still, power transmission will take place continuously. And data analytics are playing an important role in the modern industrial systems. Most of the as of today, this analytics became a buzzword. Then what is analytics? Analytics is known as the scientific process of transforming data into insights for making better decisions. Then we will use certain techniques. That is what we call linear regression, non-linear regression, random forest, several methods. What we are calling the analytics is some scientific process. We put some algorithms. And if you see one more, this is driven by the development of information and communication technology, because without information communication technology are playing a vital role. And information layer is added to the conventional electricity transmission and distribution network for one, data collection, storage, analyze with the help of wide installation of PMUs. Why is PMUs? Smart meters, IEDs, intelligent electronic devices, sensors, etc. Therefore, we can get the data from several sources. And because as we have seen, in case of, as I was mentioning from the beginning, the neural network data training and testing only used to come. But whenever this machine learning is coming into picture, people are talking ML, AI and all that, it is nothing but statistics. Because all the algorithms are based upon the statistics. Therefore, a person is statistics as well as the probability. When these two, when you have combined, this machine learning is a part of that one only. Therefore, another point, dealing with huge amount of data from electricity network, meteorological information system, geographical information system, etc. Many benefits can be brought to the existing power system and improve the customer service as well as social welfare. And one more thing is that with the fast development of digital technology and cloud computing, more and more data are produced through digital equipment and sensors such as smartphones, computers, advanced measuring instruments, etc., as well as through human activities and communication. And as and today, the size of the data, if you observe, good old days, if you observe the size of the data, memory is required. Memory plays a vital role. Good old days in the 80s and all that, 70s and 80s, late 70s and beginning of the 80s, the computer, if you take desktop, there are no laptops at the time, only desktops. They used to have memory 256 kilobytes, that's all. Therefore, to handle the very large data is become very, very difficult. As in today, even if you see our smartphone, they will have the gigabytes of the memory they will have. Therefore, as in today, whatever the data we are getting through internet or several sources, the data 10 to the power of 18, we are calling exabytes, and 10 to the power of 21, we are calling zettabytes. That much of large data we are getting through several sources. Therefore, whenever we are having the large data, we have to analyze. Therefore, the processing and analysis method of this large volume of data is the new challenge. So whenever there is a challenge is there, opportunities also will come. Therefore, when data is there, what to do with this data? That is a challenge. The opportunity based upon this data, we take the opportunity by using the big data analytics, etc. and all that. From that one, I will convert the data into certain different models, and from that I will take a decision I can take. Therefore, every operation of the smart grid or operation of the power system will become very smooth. And one more word, if you observe, I introduce smart grid and super grid. Then what is the super grid? The super grid is a wide area. Okay, if we are talking about PMUs, we use a wide area. Super grid is a wide area transmission network that makes it possible to trade high volumes of electricity. When we are talking about trading means there's selling or purchasing high volumes of electricity across great distances. I can from another country to our country. Okay, distance or other way northeastern to southern region. Distance is very large. Okay, that's why we are calling one more word. Smart grid and super grid are effective solutions to accelerate the pace of electrification with high penetration of renewable energy sources. Therefore, without renewable, the future is a blank. The data analytics based renewable energy, okay, mostly we can suppose solar is there. Whether is some the radiation and all that, okay, the weather conditions are changed. Suddenly we can predict how much power I can get. Wind based upon the wind velocity. There is most of the time this machine learning algorithm I can get the predictive modeling I will get. Therefore, they are more very helpful in the prediction point of view. Wherever in the business also. Suppose a business is there, they want to predict next 3 months what are the profits. So a car company is there, how many cars you can sell approximately. Therefore, that type of prediction we can get most of the time. These applications people are using in the business also these things. Therefore, the data analytics based renewable energy forecasting methods are hot research topic for better regulation and dispatch planning. And if you come back to the, as I was mentioning, in good olden days, we're having a meter, electromagnetic energy meter. It is used for only billing purpose. How many units means only for billing. But small data we used to get. But as in today, if you observe, the second point, while the huge volume of data collected from two-way communication, smart grids at different time resolutions used advanced data analytics to extract valuable information not only for billing but also the status of electricity network. Therefore, as I mentioned, even when we are having this electronic energy meter relative to the induction type energy meter, there is only one measurement. Here we are getting 5 to 6 measurements. If we replace this electronic energy meter by means of smart energy meter, then I will get more information I will get. Therefore, this what we are talking, different time resolution used advanced data analytics to extract valuable information not only for billing but also the status of electricity network. Therefore, a particular area you take, each household will have their way of working is different. Therefore, based upon this one, this particular area one, how much power they will consume and how the pattern looks like they can get. And one more thing is also when we are having this smart grid, people are implementing the communications and all that by sitting. As in today in my house, electricity board people, substation people, they cannot know how much energy, what are the equipments are switched on. They don't. But when it is smart, everything is made smart meter, two-way communication and all that. Sitting at the load dispatch center or a substation, he can house number one. What he is consuming. And if you want high consumption is there, suppose the generation is less and frequency is going down, and instead of shut down entire region or entire area, the substation people they can switch off some important loads by sitting at substation without the consumer may not be knowing. Therefore, that is also we can do. Therefore, the data analytics plays a vital role. For example, a high resolution user consumption data can also be used for customer behavior analysis and demand forecasting and energy generation optimization. Therefore, by using the large data we can do for the, as I mentioned, customer behavior, how his behavior is with respect to his load and demand forecasting and forecast the energy generation also and energy generation optimization. And one, as I mentioned, that is a periodic instead of periodic maintenance, one should go for predictive maintenance. I should want to predict because when based upon the large data is there, how the machine is stuff. As I mentioned in the beginning, every 6 months I want the generator maintenance. Instead of that, periodic or predictive. I'm using based on the machine learning algorithm. I can predict whether this machine will require what time it requires the maintenance. That's what we call predictive. When predictive maintenance is coming to picture, we can avoid some of the faults. Therefore, predictive maintenance and fault detection based on the data analytics with advanced metering infrastructure (AMI) are more crucial to the security of the system. When we are getting the large data, most of the time people will call as a big data. Okay, if you see the big data characteristics, okay, there are 5 V's what people will call. 5V big data model: volume, velocity, variety, veracity, value. If you see, the volume refers to the vast amount of data generated, because we are getting large data, and velocity refers to the speed at which new data is generated and the speed at which data moves around. And variety refers to the types of data we can now use. There are several different types of data: analog, digital, and all that, text, etc. Veracity. Veracity refers to the trustworthiness of the data, because all the data is there, but can we believe this data is okay or not? Because most of the time, if you see our normal case, the data from RTUs, it is going through communication channel to the load dispatch center. Then what is the need for the state estimation? The state estimation algorithm is required because data might have corrupted, some noise may be incorporated. Therefore, to filter the noise, we are using the state estimation algorithm. Therefore, when we are having the large data, one of the things is that veracity, that is trustworthy, whether we should check whether data is okay or not. And value refers to our ability to extract valuable information from the huge amount of data. Therefore, how we can extract? By using certain algorithms. Then we can take certain decisions. For this data, can be classified three categories one can classify, that is measured data, business data, and external data. Therefore, this measured data is nothing but just like whatever we are measuring by means of the smart meter or PMUs, or as well as the sensors, or by using normal meters and all. That is the measured data. What is the business data? The business data mainly includes marketing strategies and rivals' behavior. Suppose a Hyundai company is there. Their rival is, let us say, Maruti Suzuki. Therefore, they can predict or they can make some strategies such that their rival should not succeed. And these marketing strategies, as I mentioned, that is how many cars I can sell. Okay, that's several. How many profits I can get within the next 2 months or 3 months or 6 months, long term or short term, whatever it may be. Therefore, that is what we call a business data. Therefore, that is why when you are using this analytics like small multi machine learning and all that, people will call business analytics. Okay, and external data, it is based upon weather conditions and social events like festivals, or the external data that cannot be measured from smart meters but have an impact on the operation and planning in power system. Because whenever social events and weather conditions change, we have to plan accordingly. And intelligent data collection devices in smart grid, as I mentioned, several data collection is the AMI, advanced metering infrastructure. It is nothing but integration of, what is the AMI means? Integration of smart meters, data management systems, and communication networks provide bidirectional communication between customers and utilities technology. What is the application? Remote meter configuration, dynamic tariffs. That tariff is dynamic, as I mentioned. As I'm today with respect to Indian scenario, tariff is static only. Anytime you use, peak time you use or off peak time you use, your cost is same. But dynamic tariff means when you peak hours you want to use, the cost is more. Off peak hours, the cost may be less. At night, suppose normal case, 5 rupees per unit, as I mentioned, if the peak hours, for example, cost is very high, like 20-25 rupees. People will hesitate to switch on their ACs, what I mentioned. And off peak hours, night 2 o'clock, the consumers are less. The generation is more. I can make it 1 rupee per unit or 50 paisa per unit. Then I will encourage during that night o'clock. That is the tariff is changing dynamic. How we can note the tariff is changing dynamically when you are having a smart meter. Without smart meter, we cannot know what is the cost. And one more thing is that this Phasor Measurement Unit for to get the synchronized data, and WAMS, a wide area monitoring system, remote terminal unit, and SCADA, supervisor control and data acquisition system, IET, intelligent electronic devices. So these are some of the data collection devices. And if you see the communication infrastructure, people will talk, as I mentioned, home area network. Therefore, home in our home automation, what we call, okay, in this one, and one more network. What is the neighbor area network? Is nothing but several houses, home area network. They will become neighbor area network, and this WAN, wide area network. These are what are the different networks with respect to the spot. And what is the for the data analysis, what algorithm, what mathematics is required. Therefore, statistics. I was mentioning statistics, probability. Okay, what is statistics says? The study of data collection, analysis, and interpretation with mathematical methods, which may discover potential relations based on some hypothesis. Statistics, machine learning, data mining, pattern recognition, and deep learning. What is deep learning? It is a branch of uh, neural network. If you see, just I will throw some light on this deep learning. People are talking in power system, the deep learning. Compared to the neural network, normal neural network will have some input layer, hidden layer, output layer, and all that. Some input is given, and our network has trained or learned. Then I can test. As the time of testing, I will get some output. There is a shallow neural network. Therefore, in case of deep neural network, some of the algorithms, what we call convolution neural network, recurrent neural network, as well as the reinforcement learning, etc. and all that. Therefore, in this deep learning, what advantage I will get from the shallow neural network, whatever you are talking in the general neural network studies, so algorithms will come to picture. Supervised learning, unsupervised learning, and in that one, in the supervised learning, the back propagation algorithm will place a vital role. That is to understand. That is the first algorithm one should learn. Then we can have radial basis function and self-organizing math, etc., etc. Therefore, the basic difference is that in the deep neural network, here we will have one input layer, one output layer, any here also, but in between several hidden layers will come. Those hidden layers are several types, and we can process those things. But here, when we are using this deep neural network, a conventional laptop or desktop with CPU may not be effective. If you won't have, because several hundreds of deep layers, hidden layers will be there. People are using GPU, graphical processor unit. When you are using this graphical processor unit, it will have the fastness enhances. That is one of the deep neural network, or people call DL. And artificial intelligence is the study of intelligent systems and agents with the ability of learning from circumstances and solving problems. Therefore, this artificial intelligence is one umbrella. Under this, we can talk about even deep learning, the machine learning, neural network, several aspects. I was mentioning this supervised learning, unsupervised learning, one more learning, reinforcement learning. How people are using this reinforcement learning also playing a vital role. Okay, and in the machine learning point of view, there are different algorithms. Okay, decision trees, navy Bayes, K-nearest neighbor, etc. Whereas in case of we talk about only neural network, supervised learning means we will have this back propagation algorithm. Supervised means input data will be required and correspond tag. Desired output is also required. That is one set, supervisor. Unsupervised, only inputs will be there. There are no desired output is not provided. Most of the time, based upon whether my algorithm is supervised or unsupervised, if unsupervised algorithms are there, it is used for the clustering. I want to make some groups for that algorithm. People will use unsupervised learning. Supervised learning, they can use for any pattern recognition problem or any type, they can make it. Because supervisor is there, he will take care of. Okay. But most of the time, this unsupervised learning, it will make for the classification problems or clustering problems. Okay, grouping. I will give simple example. Suppose in the class of 60 students are there. In the first day BTech is there. In the class 60 or 70 students are there. If you are assuming all students are from different institutions and different colleges in the state, if they are attending, in the first day, if you observe, when class is over, all the classes after 1 o'clock, when they want to leave for lunch, one will go to north, one will go to south, I will come, and they will come back. But that means in the class, in the first day of the BTech, UG, we are having 60 clusters are there in the class. But if you observe after 15 days or 2 weeks after, they will move in groups. These 5 students will move in a group, 3 students will move in a group, 10 students will move in a group like that. Then who told the 5 should become one group? 3 will become one group. That is, they will become a group. There is no mathematics, observation, similarity. To have the friend, one similarity is sufficient to have the friend. Suppose a student has, for example, how they became a group has become one class of 3 or 5 or 10, whatever it may be. Suppose a student has gone to library, you might have seen his classmate. He want to make friendship with him because He is also interested in studying. He is also interested in studying. Therefore, they will become friends. So another person has gone to sometimes a hotel. He had seen his friend in what he thinks or cinema hall, whatever it may be. It will become at least weekends. We can go along with him for watching TV, or watching movies, or having lunch or dinner on Saturday, Sunday at a hotel and all that. Therefore, this making clustering, grouping. One group may be interested, that group is or studying, another group may be interested to go for a outing like that. Therefore, these are based upon supervised and unsupervised algorithms. It is as a buzzword, and some institutions they are starting AI and machine learning also as an UG from this semester. IoT as well as the several aspects are coming into picture. Therefore, what is machine learning? Machine learning is a form of AI that enables a system to learn from data. It should learn from the data rather than explicit programming. However, machine learning is not a simple process. As the algorithm training data, it is then possible to produce more precise models based on the data. So therefore, data is very, very, because we have seen 5 V's, the big data should be trustworthiness should be required. When you trust the data is more accurate, my output, my model is also accurate. When model is accurate, my decisions are accurate. So data will play a vital role. The second point, if you observe, a machine learning model is the output generated and train the algorithm, because most of the time the neural network what you use training and testing. What is the training? What you are mapping input and output. Therefore, any learning algorithms, learning or training, data will play a vital role. After training, when you how you will train based on the algorithm. Suppose when I use the word in the case of neural network BPA, what for the BPA algorithm? It is used for the training. What is the BPA algorithm? It is a steepest descent optimization algorithm. That is why one of the problem bottom, because it is for the to train the network when you are using BPA backpropagation algorithm. This BPA is based upon the optimization techniques. That is steepest descent. The steepest descent is some limitations that can land in the local optima. When steepest descent method, optimization method itself, landing in the local optima, if you are using in the BPA, it will also land the same. Local optima problem will come to picture. That is one of the limitations of the backpropagation algorithm. Okay. After training, when you provide model with an input, you will be given an output. For example, a predictive algorithm, because there are several algorithms are there, predictive as well as descriptive and all that I will talk later. For example, what mostly this predictive algorithms will prediction. Okay, predictive analytics, there are several algorithms, what you have seen, regression and all that, will create a predictive model. We can forecast. Okay, then when you provide the predictive model with the data, you will receive a prediction based on the data that train the model. Model is we will get the basic difference is that neural network and this one I will get the out as a model. From the model I can get the output. The machine learning is a class of software that can self-improve with exposure to useful data. It is the basis of AI that involves machines self-developing models to process data and make predictions. As I mentioned, these analytics are three categories. One is the descriptive analytics, predictive analytics, and prescriptive analytics. Mostly we will use this predictive analytics, what I have talked. Therefore, then what is this descriptive analytics? It describes the problem. That is what to do with the data look like. What do the data look like? That is to describe the problem. We are calling it the descriptive analytics. And predictive analytics, I want to predict something, load or whatever it may be, or my profits. In this one, predictive analytics, statistical models are used. And here it talks about what is going to happen with the data. That is, as I mentioned, I can predict based upon the future data. Then I can predict what is my profits or loss, whatever it may be. Therefore, one more thing is the analytics. prescriptive analytics. What is the prescriptive analytics? We require optimization techniques, simulation algorithm, etc. What decisions can be made from the data? That is action to do something. Okay, then we can take into go to action based upon this prescriptive analytics. Therefore, these three analytics, descriptive analytics, predictive analytics, prescriptive analytics will play a vital role. Out of these three different types of analytics, the predictive algorithm is very dominating. Okay. AMI, as I mentioned, AMI is nothing but smart meters together with the communication network and data management system constitute advanced metering infrastructure. AMI, we have seen AMIR, AMII, and all that, which plays a vital role in power delivery systems by recording the load profiles and facilitating bidirectional information flow. And AI, ML, and data mining, and also there are related terms. Data science, what we call some data science. Okay, because you have some institutions you may be knowing they are starting BTech data science also. Data science, BTech AI and ML, BTech IoT, and different. AI is a branch of computer science that aims to program computers to perform tasks in more intelligent and human-like ways using reasoning, using reasoning and decision-making techniques modeled after human intelligence. As I mentioned, if you want a human-like intelligence is required, we require this some statistics as a machine learning plus automated reasoning. Reasoning is a must. Without reasoning, you cannot make like a human intelligence. Because a human being, the nature is different because of his common sense. Common sense is nothing but a wisdom, what we call. The second point, machine learning is a category of computing with AI focused on programming machines, that is computers, to learn. Learning is to gather necessary data or example to learn to make data-driven intelligent decisions in a more automated way. Data mining uses statistics, machine learning, AI, and immense databases of information to find patterns. Because everything you use, whatever your statistics or ML, machine learning or AI, anything, a data is required. Therefore, from the data, what are the patterns? How it is changing? What is okay? All the data is like numbers, but if you make it proper use, then you can find patterns. Just like we have seen load forecasting, clustering, several applications we can use. From that, we can make some decisions, provide insights, create classifications, identify problems, and deliver detailed data analysis. To achieve generalization in the spam filtering, most of the time the mails, most of the people use whether the mail is a spam mail or correct mail. Then they will use machine learning algorithm. What spam mail? How we can different? Based upon the wording, it is trained because training is required. Some words are there, it will identify the spam. If these words are there, not there, it will become a regular mail. Most of the time, sometimes we will use that is I have given a mail, but it has gone to spam. But classification is wrong classification because based upon some words in the mail. Therefore, and one more thing with respect to some last elections in Andhra Pradesh, what people use for the prediction point of view, because predictive analytics, what we are using, which party will win in the elections, they can use the predictive analysis. What they will do, they will make some age, the artificial intelligence based. Last time in the elections 2019 or so, 18 or 19, the prediction is based on AI. Then what they will do, they will make some age group, some 18 years to let's say 25. What they are expecting, they will ask different questions. 25 to 40, their prospects are different. Some 50 to 60 or 65. Therefore, when they are changing, therefore accuracy enhances. Therefore, if that data is given to that these predictive algorithms like non-linear regression, etc., and all that, then by accuracy, which party will win based on what, then accuracy will be more. Therefore, to achieve generalization in the spam filtering task, coming to this mails, which is the spam mail, which is the correct mail, and all that. The learner can scan previously seen emails and extract a set of words. The words will play vital role. Extract a set of words whose appearance in an email message is indicative of spam. Then, when a new mail arrives, the machine can check whether or are the suspicious words appearing. Because we are trained, if these words are there, it is a spam mail. Otherwise, a regular. Therefore, it will check for suspicious words. If the suspicious words are there, it will go to the spam and predict its label accordingly. How it predicts suspicious words are there, it is spam mail. If those words are missing, it is a regular mail. Such a system would potentially be able to correctly to predict the label of unseen. However, inductive reasoning might lead us to the false conclusions. And most of the time, what we're talking, human way of human learning is required. Therefore, the reasoning is must. Therefore, humans can rely on common sense to filter out random meaning, less learning conclusion. Once we export the task of learning to a machine, we must provide well-defined, crisp principles that will protect the program from reaching senseless and useless conclusions. Therefore, the development of such principles is the central goal of the theory of machine learning. There is a machine learning concerned with the design and development of algorithms that allow machines to learn, that is, improve and performance over time based upon the data. Based upon the data, they will go on learning. Because any new data is also coming, they will go on learning and all. Therefore, the complexity, okay, when we will go for the machine learning algorithms, based upon the complexity, okay, that is when the task, like elections, which party will win, is very, very complex. Therefore, tasks that are too complex to program, okay, also we will go for the ML. Task performed by humans, that is driving, speech recognition, and image understanding, okay. And tasks behind human capabilities, the data, as you have seen, astronomical data, weather prediction, web search engines, etc. And analysis of genomic data, turning medical archives into medical knowledge. And adaptivity. And many tasks change over time